Okay, let me ask you a question. Are your cleverest engineering tricks actually holding your AI agents back? And what's the one bitter truth the top AI labs know that maybe you don't? Today, we're going to dig into a really hard-won lesson from the front lines of AI development, and it might just change how you see this whole space.
You know, for years, the way we thought about making AI agents smarter was to build these complex, clever systems around them. But what if that's now just the completely wrong way to do it? What if all that fancy engineering we're so proud of is actually just getting in the way?
See, for a long time, we really needed this stuff. All this scaffolding like RAG, search trees, custom tools. It made sense because the models themselves were, well, they were weaker. We were compensating. But the new reality is totally different. Today's big frontier models are so incredibly powerful, they just bulldoze right through these old ideas. So the question isn't how fancy is your agent stack anymore, it's how strong is the model that's actually driving.
And hey, this isn't just a theory. We have a perfect, super recent example, Gemini 3.0, with zero, and I mean zero, special agent harness bolted onto it, just came in and completely dominated the Terminus benchmark. I mean, look at this. Out of the box, it did better than most of these custom-built combinations of a model plus an agent. It's just a raw demonstration of pure model power.
And all this leads us to a really crucial takeaway, something we're calling the scaffolding lie. That intense focus on building these super intricate agent stacks, it's quickly becoming a thing of the past.
I mean, this quote just nails it, right? Capability beats scaffolding. All that clever engineering you're doing can actually become a hindrance. The raw power of the model is what truly matters now. And a lot of the time, the best thing you can do is to just get out of its way and let it cook.
In fact, you know all that constant chatter you see online? All the little tweaks, the context tricks, the latest prompt engineering hacks? They're only getting us these tiny marginal gains. Honestly, at this point, that whole conversation is just kind of played out. It's completely missing the bigger picture of where the real progress is actually coming from.
So if it's not about building a fancier agent, then what's the real bottleneck? What's actually stopping these models from getting even more powerful?
Well, the answer is both simple and honestly pretty profound. You can build the cleanest, most elegant agent in the world, but that doesn't improve the model's core ability by even 1%. Models only get better when the labs train them on genuinely hard stuff.
And if you just look at the history of how these models actually get better, the pattern is crystal clear. Every single time we've seen a big jump in a model's reasoning abilities, it's been because of a new, challenging benchmark. And every leap forward in agent reliability, that came from a reinforcement learning, or RL, environment that forced the model to practice, fail, and learn from its mistakes over and over again.
Okay, so what exactly is a benchmark? Let's just break it down. Think of it like a standardized test. It has three main parts. First, you've got an environment, like a little sandbox, usually a Docker container, for the agent to work in. Second, you have a clear starting point, the code, the user prompt, everything. And finally, you have a verifier, which is just a final check to see if the agent actually did the job right.
Now, an RL environment, it's built almost exactly the same way. There's really only one difference, but it is a massive one. It's all about what you do with the final score. With a benchmark, the score just measures the model's performance, and it goes up on a leaderboard. In an RL environment, that score gets fed right back into the model to update its weights. It doesn't just measure the model, it actively improves it.
Okay, so if these RL environments are the secret sauce for unlocking better and better models, the next question is pretty obvious, right? How do you actually create them at scale? How do you take all this messy, real-world coding data and turn it into these super powerful training tools?
The answer is you build a factory. That's what they did at Klein. They set up this awesome two-phase pipeline to automate the whole process. In phase one, they use subagents to automatically sift through real-world tasks and figure out which ones are good enough. Then, in phase two, another process takes that good task and rebuilds it into one of these standardized, containerized environments.
So that first phase is all about quality control. You're just filtering out the noise. And there are some really easy disqualifiers. Things like vague, vibe-coded slop. Or super trivial tasks like build a new Next.js app. No, we want meaningful, genuinely challenging problems that have a clear before and after.
All right, now when you get to phase 2 and you're building that verifier, there's a real art to it. The key is to test the final outcome, not the specific steps the agent took to get there. You don't want to overprescribe.
And there's this brilliant tea kettle analogy that explains this perfectly.
So think about it. A good verifier is like a tea kettle's whistle. It cares about one thing and one thing only. Is the water boiling? Yes or no? It doesn't care if you used a gas stove, an electric kettle, or a campfire. It's totally method agnostic. Bad verifiers, on the other hand, get bogged down in all these irrelevant details, like checking which burner you used or if it took exactly 5 minutes. They're testing the method, not the result. And the result of automating this whole factory process has just been incredible. What used to take a person 16 hours of manual work to create just one of these RL environments now takes less than 20 minutes. So the bottleneck isn't the engineering anymore. It's just finding enough high-quality tasks to feed the factory.
So you can see just how powerful this process is. And that leads us to a really critical and frankly unspoken problem that's happening right now in the AI industry.
So here it is. Let's just drop the truth nuke. The unspoken secret in the AI world is that every single major agent lab is already doing some version of this. They're all doing it behind closed doors, and they're all capturing this incredibly valuable data.
And what this creates is the hoarded data problem. See, these big labs, they collect all this priceless data from real engineers working on real problems, and then you'll hear them cite their amazing performance on these internal benchmarks, but you can never actually see them because they never publish them. This data is the single richest stuff for improving models, and by keeping it locked away, they are slowing down progress for the entire research community. So to try and fix this, Klein is announcing Klein Bench. It's their attempt to finally create a public benchmark that isn't, as they call it, cosplay engineering. You know, it's not about asking an AI to generate the Fibonacci sequence again. This is about real, gritty, actual software development. And here's how it works. It's all completely open source, no secret sauce. Anyone can download, run, and inspect these environments. You can use them for fine-tuning, for reinforcement learning, or just for evaluation. The whole goal is to give the entire ecosystem a real, solid foundation to measure and improve models on. And the best part? The community can help build it, just by using the Klein provider on their open source projects and opting in.
And all of this really points to a wild and fascinating future. I mean, think about it. What happens when these models get so good at solving these hard problems that they can start to create their own training grounds? What if agents could learn to build their own RL environments, basically completing the learning loop entirely on their own? Now that is something to think about.